computer. Got it. Start video. There we go. I look amazing. Look at that.
Yeah, he's here.
And then we'll share the screen, desktop. Okay, everybody can see everything and hear me and yada, yada, yada. Okay, so before we go on with more Android stuff, are there any questions about the midterm that you want me to review or do anything sample stuff before we jump back into Android? Everybody's, go ahead. Example of a normal array? Yeah. Okay. Here, I'll do it here inside of card parser. So the request was for an example of like a normal, well, here. Comment down there, so I'll just comment this guy out. An example of a normal array. Well, just to clarify, all the quizzes you can see now, right? Like the grades for quizzes? Yeah. All right. I had it flagged as a test. So that's why it didn't show up in the grade center, because it was a test. Because even after I went and hit the button again, it still wasn't showing up. All right. So in any case, we if we're going to create an array, so let's just create an integer array. So I'm going to create a variable of type int array. I'll go ahead and name this guy AR, and we're going to request some new memory. And let's give ourselves enough memory to hold 10 integers. Remember the new keyword. The new keyword here is our real estate agent. It's going to go and ask for memory from the operating system. How much memory? This many buckets to hold this kind of thing. So that an int's 4 bytes. This is 10 of those. So I need 40 bytes of memory right next to each other. So this creates 40 bytes of contiguous memory. All right, that's the differentiating factor between an array and an array list, like from the quiz, is arrays need to be in contiguous memory, but we also specify how big they are when we first create them. All right, so now we have this array. If I want to go ahead and fill it up with some stuff, I can write a loop for int I is equal to 0. I is less than AR.length. That's the number of elements that are in AR. It's actually not the number of elements, it's the number of buckets that AR supports. All right, and right now, why don't I go ahead and just say AR at bucket I is equal to, I don't know, I times 2 or something like that. So we'll put in a 0, a 2, a 4, so on and so forth. All right, so that will fill up that array. Oh. So now if I do a system.out.println AR, what should the output of this program be?
Turkey bacon.
Close. But now that you spoke up, why don't you answer the question? What's the output of this program going to be?
2. This is a sign.
Stop
signs may seem straightforward.
The contents of AR times 2.
Depending on the circumstances.
I joined late. I'm sorry.
Off and actually look at the code. So look at what our code does here. We create a new array. We come up and we fill the array here. And then I output AR. What's the actual output of this program going to be? What am I going to see on the screen?
Does it print 10 times 2?
Okay, why do you think 10 times 2?
Because new int and then, bucket 10. Oh yeah, it's going to print bucket 10 times 2. Is that what it is?
Not even close.
Oh, okay.
All right, so pay attention to the explanation here. Go ahead. Yeah, go ahead. Nope. Next. That was your answer? Go ahead. It's going to be a memory address. What's AR? AR is a variable. What does this variable hold? It holds a value. What's the value it holds? Well, I see the new keyword here. That's a real estate agent. It's going to be a memory address. So if I run this, oh, do I have an error in one of my other, here, I have an error in card parser for the moment. Give me a second. Let's comment out wherever that issue is. Nothing to see here. All right, so there's our memory address that it prints out, because what are we printing out? We're printing out the value of AR. AR is a variable. It holds a value. What value does it hold? It holds a memory address. Now, if I were to say, show me what's in AR at bucket 3, that's going to give me a different value, right? This is going to give me a 6. AR at bucket 3 is one of the elements in AR. Go to position 3 in AR. That is, since it's in contiguous memory, go to this base memory address, then take 3 integer size steps forward through memory and tell me what value you found there. So this is going to be the integer that lives at bucket 3 of that array, or the integer that lives at memory address AR plus 3 times the size of int, which is 4 bytes. So the base address plus 12. And this is going to be the number 6. How do we know that? Because we put at bucket I whatever that value was times 2. So bucket 3 would be 3 times 2. That's just what we hard coded in there. There's our 6. That make sense?
Could you print like bucket 3 through 5 or something like that by putting a semicolon after the 3, then 5?
No, if you want to write, if you want to do bucket 3 through 5, you'll say I is 3, I is less than or equal to 5, I plus plus, and then you'd print out AR at bucket I each time. Now, that's actually a good, bad question that was just asked. And the reason it's a good, bad question is, even if there was a shortcut for printing out multiple values in an array, because Python has a lot of things like that. If you don't know it for sure, don't use it. Don't ask, can I do some sort of magic trick that just solves the homework or solves the question? 99.999% of the time, I'm asking you to use the tools that are in your toolbox to solve the problem. So if I say print out all the elements from bucket 3 to bucket 5 in the array, well, you can print out AR at bucket 3, then print out AR at bucket 4, then print out AR at bucket 5, or you can write a little loop that goes through and prints out AR at bucket I, where I is 3, then AR at bucket I, where I is 4, then AR at bucket I, where I is 5, and get the contents of the array. That make sense? Don't immediately dive in and expect that there's some magical function that just solves the exact question that I'm asking. Remember, programming is the skill set. That's what we're trying to learn how to do. Okay? We're not memorizing magic tricks or special functions in languages. We're looking at base core programming skills to do these things. So always default to, he probably wants me to do this the long way, or doing this the long way is probably the way that's going to best practice my skills. Once you get better and better and better and you find little shortcuts to things, that's when you can start using those. Make some sense? But always read all the code. If somebody says, what does this code do? Make sure you go through it line by line and ask yourself, what are we actually accomplishing here? Don't just glance at the code and try to make a guess at what this guy's going to print out or something. All right. So does this cover what you wanted me to do with arrays? You want me to do something else? Sure. So let's say we're doing the same thing in an array list. So he wants to see the comparison between this, which is a stock array, and then an array list capable of holding integers. I'll cheat. Well, here, I'll ask you. Do you want me to make an array list that holds integers identical to this, or do you want me to create an array list that maybe holds strings or something like that? Okay. Because an object's an object, but to hold primitive types in an array list, Java makes totally possible because it allows the integer class to be a kind of a placeholder for an int primitive type, but it's a little bit of a Java doing some magic behind the scenes for you. Strings, I think, make more sense, but still at the underlying level here, it's, hey, if I want to hold a collection of an arbitrary number of things, I don't know if I need 0, 1, 2, 5,000, array lists make sense for that, whether we're holding integers or holding strings or whatever. So for an array list, we'll create a array list, and I'm going to say this guy's capable of holding strings. And we're going to call this guy AR2, and he's going to be a new array list capable of holding strings like that. And we're going to have to import java.util where our array list lives. Okay, so that just got popped up there. So now we have access to array lists. All right, so now right now, notice the difference right off the bat that when I built my array up here, I had to specify the number of elements that are in this array. For my array list, I did not. I said, I have this bucket. We can think of it like a bottomless bag that exists, and I can start putting stuff into this bag, and it will just go ahead and do whatever magic it needs to do to accommodate the number of elements that I have in there. All right. Realistically speaking, under the hood, because this guy is called an array list, it is probably built on top of contiguous memory. What it probably does is when you first built it like this, it went ahead and said, okay, I'm going to go ahead and reserve 12 buckets of memory. And we're going to hope that's enough. And then if you put a 13th thing in there, then I'll go ahead and do all the behind the scenes destruction stuff. You don't have to worry about it. I'm taking care of it. And you could put more stuff in it. But it's probably implemented across a contiguous memory, which should tell us that anything that is an array, whether it's a primitive type array or has the word array in it, which probably indicates that it behaves like an array, is probably relatively fast. So for us, we can look at this guy as kind of like, it's our convenience of having the benefits of fast memory and at the same time of having flexible size where we can just add stuff to it. All right, so here's my bottomless Santa bag, so to speak here. And now I can go through and I can say for int I is equal to 0, I is less than, and let's just say we're going to put 10 elements in here. Now I can't say AR2 dot size because AR2 size, here, I'll go ahead and finish writing it here because you might feel like, oh, well, I need to do it like this. And then we'll say AR2 dot add element, and here we'll just do the empty string concatenated with I times 2. So we'll have the string version of the same values in there. So up here we built a plain Jane array and then wrote a loop that went through and filled the entire contents of that array up with some numbers. Down here, we created a brand new array list, and we tried to write identical code here with the presumption that we want to go through that whole array list and fill it up with also a string representation of some numbers. The difference here is that up here, AR.length was 10 because we built AR to hold 10 integers. What's the size of AR2 right here? How big is AR2? I built it right here. How many buckets does AR2 have in it initially? So 0 right now, right? I haven't thrown anything in there. So its size is going to be 0. So we're not going to add anything to this. This loop will go through 0 times right now. If I wanted to add 10 things in here, I'm going to have to say, I want to go through 10 times. Take I on a journey between 0 and 10 not including, or 9 inclusive. And each time through, go ahead and add to my bottomless Santa bag, my array list, add to it whatever I is times 2, so the same numbers we did above. And then I went ahead and just to review this, I turned it into a string. Remember, Java's a string-based language, so with Java, we can use the empty string like this and concatenate stuff onto it and conveniently get almost anything turned into a string. So this will fill that array up with 10 values. Here, I'm going to go ahead and take this for loop out here in the middle, just so we are comparing kind of apples to apples. So if I go system.out.println AR2, what's the output of this program going to be? Memory address. Again, right? What's AR2? AR2 is a variable. Variables hold values. What kind of value does this guy hold? Well, I see the new keyword there. That means it's going to hold a memory address, which will point to a place in memory where this actual array list lives. So I go and run this. There's my, oh, actually, that is fascinating. All right, so it didn't give me a memory address, but you're right that it is a memory address. What it did is there's a method inside of array lists, and we're going to write this ourselves. Have I talked about toString yet in here? Maybe not. Okay. The object class, the top level object class, gives us a generic method called toString. That means every single object will automatically have its own toString method. And because of that, the default toString method shows the weird memory addressy thing. Since I'm seeing this output here, that means that AR2, which is an array lists have written their toString method. They've overridden their toString method to actually show you the contents of the array list rather than memory location. And I'll prove this here by actually calling specifically its toString method. And you'll see it's going to give me the identical output. Because this println thing here, what it did is it called this guy's toString method. And array lists happen to make their toString method show the contents of it rather than the memory address. If I do this, I don't think, I still think this is not going to work. So if I typecast AR2 to an object, I say, don't treat this guy as a string. I need one more guy. Oops. Ninja. So now I'm saying, treat AR2 as a plain Jane object. That's all fine and dandy. So as of right now, it will treat it as an object, but it's still going to, the way object-oriented languages are built, when you call a method like this, what it's doing is it's doing something called message passing. It's going to send the message toString to this guy, whatever this guy is. I've said treat him like an object, but he is what he is. Yeah, I could put you in a costume, right? But you still are who you are. All right. So if I'm going to send the message to this guy saying, hey, call your toString functions just like variables resolved to their most local definition. So even though I'm telling you this guy's in an object costume, he's still a string, or he's still an array list in this case. And he's going to try to call his own toString method, and his own toString method does already have stuff in it, has this stuff in it. If I was inside of array list toString method, I could, if we really wanted to fake it, we can do this. What are we in here? This is 250, this guy. Actually, I'll fake it inside here just to make it quick. I'm going to say public class my array list extends array list, and then I'll say public string toString. I'm going to return super dot Is that going to let me do it? Super dot toString. I'm trying to go up 2 levels because my array list super is array list. Array list super is object. Super dot. Can I ask this guy for his parent? Let's see, we have to be, super is a private variable. We would need to be inside of the array list class to get it. Yeah, I don't think we can pull it off. We'd have to write our own array list to do it. So because array list said, hey, when you print us, you're calling our toString method, because that's what the Println function does for objects. So if you remember looking at the Println method in the documentation, Java system, actually we'll just do, well, I can follow just the system class. And then we'll system.out is a print stream, and then we'll see down here we have a bunch of printlns. So here's our println. So we have one that knows how to do booleans, chars, char arrays, doubles, floats, ints, longs, strings, but then we have the catch-all that says, look, I can print any object that you want, but what will I do? I will call that object's toString method, which he is guaranteed to have because all objects have a toString method that at the very least will show you the memory addressy looking thing. But in this case, we're dealing with an array list object that has chosen to write their own more local version of the array list method or the toString method that shows the contents of it rather than crazy memory address. Figuring that that's a practical thing, right? You have an array list and you print it out, you probably want to print out the contents of it. But it's actually an important example because just because this showed me the contents of AR2 instead of a memory address doesn't mean that there's anything different with this line than this line up here. I'm printing out the value of this variable. I'm printing out the value of this variable. And the Println method, when you give it an object, because this is an object and this is an object, he will call that object's toString method. It just so happens that this object's toString method is the one from the original great-great-grandparent object, which just shows you a memory address. It just so happens that array list in this case has implemented their own version of toString. So this isn't like an exception or a hack. Both of these are doing the same thing. We're getting different results because of a decision the people who wrote array list made. All right. So that gave us the contents there. If I wanted to then say system.out.println ar2.get3, that's how I'll access bucket 3 of that guy, as opposed to up here, I would have said AR at bucket 3. And I'll get my 6 twice. Just so happens, though, this is actually the string 6. So if I said I want to add to this guy a 4, I want to add to this guy a 4, this is going to become a 10, this is going to become a 64 because it's a string and the plus sign will be treated as concatenation. All right, so that's actually a pretty good exercise we just did in reading code. Got to be able to walk through the code and say, what does this guy actually do? That's a skill that you want to get. You shouldn't have to run the program in order to have a pretty good idea what that program is going to do. And it's something that you probably should practice doing. You see me doing it in class all the time when I'll ask, well, what's the output of this going to be before we run it? You should do that yourself when you're writing your code. All right. Does that cover array lists for you? Want me to do something else with them? Actually, let me just do one more quick little thing. I can say ar.size here, ar2.size. Now, since I've added 10 elements to it, it will now have a size of 10. So now he'll report his size. And this 10 is different than this 10 because this 10 just happened to be the math equivalent of 10. So let's not confuse the issue there. Okay. Why is the size of my array list 10? Because I just shoved 10 things into it. If I change this to be 10,000 things, now its size is 10,000. I put 10,000 things into this bottomless Santa bag. All right. Questions about that? Anything else you want me to cover with array lists? Okay. Anything else you want me to review? Go ahead. About parsers? Can you give me more information on what you're looking for? Okay, like what's the job of a parser? Okay, so the job of a parser, just in general, you know, let's give ourselves an example here. So let's say I have a string S, and let's just say this string has a 5, a 3, a 2. So I've encoded my values inside of this string where I have 3 numbers and they're separated by commas. All right. And so the act of parsing would entail extracting my 5, 3, and 2 from this string. We parse those values out of our string. All right. Now there are some built-in tools in Java to let us do this, but let's just assume we don't know that. So now what we want to do is we want to create these values from here. So when I get this string, so here I'm actually going to write a function. So we'll say static array list of strings. String, this guy will take in a string S as a parameter. So we're going to pass him something like this, like our string up here. So I have my string S, and I'm going to go ahead and say array list of string. We'll call this answer is going to be equal to driver.parseString, and I'll pass it my string I just wrote here. So here's my method parseString. Notice it's a static method. It's owned by the class, so we call it with the name of the class in which the method was defined. So I'm going to say driver.parseString. I'll pass it S. What is S? S is a string that looks like this. So it's a string divided up by commas. And we're going to say, well, we don't know that there's a split method that'll go ahead and split this up for us. So we want to go ahead and do this ourselves. So we're going to write a parser for this guy. So we're going to create an array list of type strings. And right now that array list is empty, nothing in it. Why did I create an array list rather than an array? Because I don't know how many values I'm going to bump into inside of my string. I just know that there are some values encoded in my string that are separated by commas. I don't know how many. Array list is the perfect tool for that, right? So now what I'm going to do is I'm going to start walking through every element of my string. So for int I is equal to 0, I is less than s.length, I plus plus. Why s.length? S.length is the number of characters in s, whatever s is. Remember, s is the parameter coming into this function. Therefore, you know, the idea of a function, it's a reusable chunk of code that you write once and people can call multiple times. So they might call it 5 different times with 5 different strings. So you can't make some assumption that it's a hard-coded string. How many characters are in s? S.length number of characters. That's what's in S. All right. So I'm going to go through here. And what I want to do is I want to collect characters until I hit commas. Once I hit a comma, I know I'm done collecting the first number. So if I think about it from up here, I can say, here, let's actually change this like a 52. And then a 333 and a 2. We'll leave the 2 alone. So I'm going to collect a 5, collect a 2, but then I hit a comma. I say, I finished collecting a value. I'm going to go ahead and add that to my array list and reset. Collect a 3, collect a 3, collect a 3. I hit a comma. So I'm done collecting my next number. I'll add that to my array list, reset it. Collect a 2. I hit the end of my string. I have one last thing that I trapped inside of my collection. I'll go ahead and add that to my array list and return. So I'm going to need a temporary variable here. Start that off as the empty string. We're going to say if s.char at I, if the current character I'm looking at is a comma, then I know I've finished capturing one of my numbers. What do I do with it? I say ar.add temp. I'll go ahead and put that number into my array list, and then I'll reset temp. Else, if it wasn't a comma, then what do? I build up temp. I say temp is equal to temp concatenated with s.char at I. Once I finish going through the whole string, I should have one last thing trapped inside of temp. So I'll say ar.add temp, return AR, and that will parse that string. You can see it work up here. I'll go ahead and do a system.out.println answer. We see our 52, 333, and our 2. So it accurately parsed it out, but I wrote that whole parser. I didn't use anything built in. I decided I knew my strings were organized in a certain way. Some number followed by a comma, followed by a number, followed by a comma, yada, 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 till you run out of space in there. So what did I do? I said, well, I'm going to be collecting numbers until I hit a comma. Once I hit a comma, I'll add the last number I collected to my array list, and then I'll empty out temp so I'm ready to collect the new number. Do that over and over again until you finally run out of characters inside of S, in which case you have one final number trapped in temp. So in our example up above, that last number that was in there was our 2. This guy was that last value because he never hit a comma, right? He hit the end of the string. So we finally hit that last number. What did I do? I went ahead and added it to my array list, and then I returned my array list. That make sense? Now, if I want to take that one little step further and kind of, add to this just a little practice with pointers, I could have said, well, what if I didn't want to return an array list here? What if I actually wanted this guy to not return anything? But instead, he took in a string let's call this, we'll call that guy answer. Let's say he took in a string as well as the array list where to put the answer. So now we have this local array list we built that we went ahead and filled up. We can do it this way, that's fine. And then at the very end, since we're not returning anything, I can go ahead and say that answer is equal to the memory address that's stored in AR. Preserve that value. I'm not saying this is the way I would do it, but this is how pointers work. This is an object, and objects are passed by reference. All right, so objects are passed by reference. So I can come up here and I can say I'm going to create an array list. Called answer, and I'll go ahead and pass my string and that array list in here, and then I'll go ahead and print out answer when all is said and done. Look, I got the empty list. Why did I get the empty list? I created my array list up here, holds nothing right now, right? Then I passed my array list, this guy, into this function. This is passed by address. So that's a pointer to that array list, the real place in memory, not a copy of it. What did I do inside of parse string? I built a new array list. I filled up that new array list with my value. And then what did I do? I said answer is equal to AR. What is the value of AR? What kind of thing lives in AR? Memory address. So AR is a memory address. Now, what happens to AR when this function ends? Is AR a local variable that was defined completely inside the scope of parse string? Yeah, I defined it right here, right? Line 51. Here's my variable AR. He's a variable that was born inside the scope of parse string, and he will die when parse string scope dies. Make sense? Which means here at the end, after this guy dies, the memory that I had requested up here will be given back. So now I set answer equal to this memory address, not the contents of it, the address itself. Make sense? And that address gets reclaimed by the operating system, which is why it had nothing in it. Now I can come in here and I can copy over. So I can say for int I is equal to 0, I is less than AR dot size, I plus plus, answer dot add, AR dot get I. I can do something like that. Now when I run it, you see I have the actual elements. Because I didn't rely on where AR was in memory. Instead, I said, give me the integer, in this case a string rather, that lives at a certain bucket, and go ahead and add that to the memory address that is answer. Add it to the array list that lives at that memory address. Now answer, he is a variable that was defined up here. So his scope lives and dies with main, which means that when I call parse string and I pass it my string I want to parse, as well as the place where I want him to put my answer, and then when that returns, even though it didn't return a value, I gave it a pointer where he can place my answer in memory. And now when I go to print that out, I get the actual answer. That make sense? So in that little example there, we looked at scoping rules, we looked at array lists, we looked at a whole bunch of stuff that's related to programming. That was a really good example, actually. It's pretty solid. All right. So I know we covered a little more than was asked, but the act of parsing is taking crap out of a string and getting the data from it. Json Parsing says, hey, they've come out with a more interesting way of organizing the data than our little hack there where we just threw commas in between it, right? That's our version of made up JSON where we said, hey, I got 3 numbers. I'm going to put commas between them. You go and pick out your numbers. JSON looks a little bit scarier, but parsing would work very similar following different rules. We're looking for opening curly braces and closing curly braces and opening square brackets and closing square brackets. That's if we wrote the parser ourselves. we used that simple JSON library that did all the parsing for us. So what did it give us? It gave us a JSON array that we can just start asking it for pieces of information. It gave us something kind of like this array list that has our stuff in it. We passed in a string, it gave us back an object that had all the stuff in it we wanted that we can go and pull out. All right, other questions? All right, the exam will be up. It actually might be up sometime today. I have time before my 450 class, so it might be up today, so you might actually see it populate. You won't be able to start taking it yet. There's just a chance you might see the exam show up in Blackboard. I know very little about what Blackboard's doing these days. Let's just be honest. I think usually it hides it from you until I actually make it available to students, but who knows? But anyways, the exam is to be taken during class time on, let's say Monday, on Wednesday. I'll have it graded before class on Friday, so we can talk about it on Friday. A couple of people in class have asked for, they already have a doctor's appointment or something, or they get different accommodations. So I'll actually leave the exam up for probably the entire day on Wednesday for you to do. The preference would be to do it during class time. So you have your class time. You don't have to do any time management or anything like that. But if for one reason or another you want to do it at a different point in time, that's fine. Just know that you are going to be limited to the class time for doing it unless you have other special arrangements where it'll automatically give you the extra time and that kind of stuff. Questions, comments, concerns, bribes? Okay, and hopefully I'll have good stories about how the Tesla handled in the snowstorm. Or not. I think they're pretty safe, and I don't think I'd be going very fast. So I probably wouldn't have a horrible outcome other than my Tesla battery died when I was trying to stay warm in the ditch. All right, I'll see everybody on Wednesday. And maybe we'll make it a classroom.
Did somebody actually make that comment?
Which one?
The one you just mentioned?
Which comment? The one about the running out of battery life while I was trying to heat myself in the ditch?
Yeah.
No, I mean it was. I mean, I'm driving back in a car I'm not familiar with during a snowstorm, so covering the possibilities.
Okay.
I think the car is really heavy though with all the batteries. I think it's handled in the snow pretty well. But I think
Yeah. Okay.
it's supposed to be warmer, so I'm pretty sure the interstates are just going to be slushy, not slippery.
Okay. Have a good one.
I'll see everybody on Wednesday.